Good morning students, welcome back to digital electronic class. In today's class we are going to discuss the QUINE MC CLUSKY method, that is nothing but the tabular method. In the previous class we have discussed the procedure how to do the problem based on the tabular method. In today's class we'll do directly numericals of that particular topic. So first thing, before going for today's class, we'll take the overview of the previous class. In previous class we have discussed the tabular method. If you want to design it, it can be done by taking the prime implicants. Then we'll take the tabular form of essential prime implicant. What is a prime implicant means what? It's nothing but the numbers, or it is nothing but the bits. When we try to combine it, we'll try to make into different index values. Index 0, index 1, index 2, index 3, index 4. So like that we'll take and we will find out the value for it. So in that we are going to take the values of it. What is a given question in this? They gave a question, QUINE MC CLUSKY method, that is our topic for discussion. In that they gave a question, minimize or consider this function for minimizing of that thing. They gave the function f is equals to wxyz of summation m of 0, 5, 7, 8, 9, 10, 11, 14 and 15. So these are the mean terms they gave. They asked to solve and try to minimize this particular function by applying the tabular method. So by doing this thing, what we'll do, we will try to first write those specific terms. What is given in the question? F of wxyz is equals to summation m of 0, 5, 7, 8, 9, 10, 11, 14 and 15. So they gave these values. So first thing what we'll do, we'll try to write those values in terms of mean. So first thing, mean term m0, then m5, M7, M8, M9, M10, M11, M14 and M15. So we had all those values. Next thing is that we will try to write the binary equivalent for each respective mean term. That means if I do have mean term M0, what I'll do it? If I do have M0 like this, what is M0 is nothing but all zeros. Likewise, if I do have M1, not M1, they directly give M5. So what is M5? 0, 1, 0, 1. So that's nothing but M5. So now like this I can take M7. So what is M7 value? I do have 0 with all ones. Likewise I do have M8. So M8 I can write it as 1 with all zeros. Likewise I can take M9. So what is M9 value I do have? M9 I can write as 8 plus 1, make it as 9. Like this I can take M10. So M10 is 1, 0, 1, 0. Next M11. So M11 I can write 1, 0, 1, 1. 8 plus 2 plus 1 is 11. Like this I can write M14. 14 is 1, 1, 1, 0. M15. So M15 I can write 1, 1, 1, 1. So first thing we done the first step. In the first step what is the thing we have converted? The given whatever mean terms we do have, that mean terms will write its equivalent binary form. That part we did. Next thing, as per the index. Index means what? As per the number of ones, we need to group this particular number of mean terms into different segregation, like index 0, index 1, index 2, index 3, index 4. Try to do it. The first thing what I will do it, this is our mean term M0. So that I can write it as index 0. So this come under all zeros are there, right? So that means it's nothing but index 0. Likewise I can take index 1. So index 1 consists of M8 because it has single 1. So anywhere is there like that? No. So this is what index 1 value. So this is your index 0. Likewise I can take for index 2. Index 2 means number of ones needs to be 2. For that particular thing we need to look into it, we need to search it such that the mean term in which number of ones comes twice. So in that what we'll take? So as you can see, this is M5, that is come under index 2. Like that I can take M9, it's also have 2 ones, that is also index 2. Next I can take M10. So 5, 9, 10. So these are come under index 2. Next thing we go for index 3. So what is index 3? The number of ones needs to be 3. So in that come under M7. So M7 also come under the index 3. Likewise I can go for M11, M14. So these 3 values come under the index 3. So likewise I can take for M15. What is M15 is nothing but it's index 4. So that index value we found. So what is the first step states that for tabular method? First step states that whenever we want to write any number, that particular prime implicant values, before getting the prime implicant table, we need to write first its equivalent binary combination. That we have done. Second step states that we need to make the given function into their respective binary combination. So that binary combination we did. Next thing, we need to segregate. We need to group into index 0, index 1, index 2, index 3, index 4. So that's what we need to group the given mean terms into different indexes. After getting it, next step is that try to compare the bits. So that comparison bits we will do now. So see students, so we are drawing, we had this tabular method. In that they gave the question f is equals to summation m 0, 5, 7, 8, 9, 10, 11, 14 and 15. In that first thing what I said we need to write that binary combination, we did it. Next thing, we are writing the index value for it. So what is the index we are writing? Index 0, 1, 2, 3, like that we'll write different index value, depends upon the binary combination. So in that what I'm taking, if I do have 0, so what is 0 I can write? I can write all 4 zeros I can write. Similarly, if you do have 5, so how do I write 5? So I can go with index 2. So 1, 0, like 0, 1, 0, 1. So 4 plus 1 make it as 5. Likewise, if I want to write for 7, so 7 will come under index 3. So like 0, 1, 1, 1. So 4 plus 2 plus 1 make it as 7. Similarly, 8. So 8 is nothing but come under index 1. So it is what? 1 with all zeros. Likewise, I go with 9. So 9 would be index 2. So 9 would be 8 plus 1 make it as 9. So that combination I'll write here. So this one, what is this value actually? All zeros. So what value I'm taking in this? That is decimal number. So decimal number is what? 0. Similarly, I'm taking 8. So 8 I'm writing here. So 8 here and all will be zeros. Likewise, I'll write 5. So here I'll mention 5. And the representation of that number I'll mention over here. So what is this actually? It's 5. So 5 is 0, 1, 0, 1. Likewise, I'll write for 9. This is what binary number, it's 9. So 9 is what? 1, 0, 0, 1. So 7 is what? So 0, 1, 1. So this is your 7, 0, 1, 1, 1. So we had these all things. Next is what actually? After getting 9, so 8 is done, 9 is done. Next we need to go for 10. So how do we write 10? 10 is nothing but 8 plus 2, make it as 10. So we done with 10, 11. So how do we write 11? So 11 can be written as 8 plus 2 plus 1. It's 11. So it's come under index 3 since it has 3 ones. So whenever we had 3 ones, that come under the index 3. Next we go for 14. So 14 also come under the same. So 14 is 8 plus 4 plus 2 plus 8 plus 4 is 12, 12 plus 2 is 14. Next is 15. 15 means it's come under index 4. So what actually we are doing, we are having the question. So that question by using the QUINE MC CLUSKY method we are applying, or by applying the tabular method we are doing. First thing, we are segregating based upon the number of ones into the respective index value. Second thing, we wrote all the decimals. Next we write binary representation of each term. So each term we represented binary, that we are done. Next thing, the decimal numbers. Next what we are doing, we try to compare it. Like this 0 I'll try to compare with next index value. So what is the next index value I do have is 1. So I can write, I can compare it. So what I am doing, I am comparing 0 midterm and I am comparing the 8. I am comparing these two midterms and I just want to write out the value for it. So how do I write? All are zeros, all are zeros. Only the bit difference is here is 0 is there, here 1 is there. That means it's 0 and 1. That means we need to put dash for it. That is nothing but either it can be 0, either it can be 1. Since we are comparing it, so we'll write dash with all remaining zeros. So that is the first comparison. So we're done with the first comparison. Second thing, we'll compare 8 with 5. We'll go for what we are doing actually. So we are going for first reduction. We try to reduce it. Whenever we are doing the first reduction, the number of comparison of the bit should be single. That means only single bit should be differ, remaining bit needs to be same. In that scenario, you need to take the combination of the bit and we need to take what is the difference of the bit, whether the bit is same or not, that we need to cross check. For that what I am doing, I am comparing 0 with 8, only the difference of the bit is what? 1 MSB. This MSB bit is differ. Whereas you can see 0 is common and 0 is common. That means first bit either it can be 0 or either it can be 1. So since we are comparing it by the tabular method, what is the statement of the tabular method? Whenever we are comparing any bit, that bit needs to be put as it is. That means it is dash with all zeros. So we compare index 0 value with index 1. Next what we'll do? We'll compare index 1 with index 2. So in that what we'll do it? We'll take first bit, that is 8. So 1 0 0 0. So next we'll compare 8 with 5. Check whether comparison is possible or not. So see, here 1 is, here is 0. Okay, one bit is differ. Again 0 and 1, 2 bit is differ. That comparison will won't do. Only one bit needs to be differ. Clear? For that 8 with 5 is not possible. Now go with 8 with 9. So what is that? 1, here is also 1. Bits are same. Next consecutive bit, it's 0. Both the end it is same. Next is also 0. Both the end it is same. Here is 0, here is 1. Oh yeah, only one bit is different. We can compare 8. Bit number 8 with bit number 9. So that we are doing. Don't put a braces over there. This is the first reduction we did. We are going for second. So in the second, what is the value? So 1, here is also 1. First we'll write 1. Next, both the end zeros are there. So we'll write 0. Another end, both the end zeros are there. Again we'll write 0 and we'll put a dash. So what we have done? We compare 8 with 9. Now just check 8 with 10, is it possible or not? So in 8, first bit it's 1 and 1, it's same. Second bit 0 and again here is 0. That is also same. Yeah, this bit is differ and this bit is same. So possible. 8 with 10 comparison is possible. So what is the answer we'll get? So 1, these two are zeros, that will be as it is. So 1 0 dash 0. So I can write like this. So 1 0, this here is 0, here is 1. That means these are differ. Only single bit is differ, remaining is same. So now 8 with 10 is also done. That means we comparing index 1 with index 2. That is also over. We got this answer. So we write it. First 0 with 1 index we done. Now index 1 with 2 we did. Next, after getting index 2 with 1 with 2, next we'll proceed with index 2 with index 3. So what we'll do now? We'll go for comparing 5 with 7. So check it out whether it is possible or not. 5 with 7, here is 0, yes. Here is 1, yes. Here 0 and 1, yes. One bit is differ, remaining is same. That means comparison between the 5, mean term 5 and mean term 7 is possible. So I can write 5 comma 7. So what I'll get the first one? 0 1 dash 1. So I'll get 0 1 dash 1. 5 with 7 is done. So this with 7 we have done. Now 5 with next bit you check. So here is 0, here is 1. Here is also differ. That means 5 with 7 is not possible. Next we'll go for 5 with 11 is not possible. 5 with 14 you check. So 0, here is 1, 1, 0, 1. So that is also not possible. So 5 with remaining index value, index 3, it is not possible. Now go for 9 with 7. So 9, here 1, here 0. 0, 1, 0, 1, like this it is not possible. So 9 with 7 is not possible. Now go with 9 with 11. So here is 1. Yes, here is also, this is possible. So what I can write? 9 with 11 is possible. So what is 9 value? 1, here is 1. 0, it is also 0. So 1, 0. So 1 and 0. Next is this bit is differ. Here is 0 is there. Here 0, here is 1. That means dash 1. So 9 with 11 we compare. We got this answer. Next try with 9 with 14. So here is 1, 0, 0, here 1, 1, 0. That is not possible. That means 5, 9. Now go with 10. So 9 also done. Remaining comparison is not possible for 9. So now next thing what we'll do it? We'll go for next comparison. So in the next comparison what bit we'll compare? We'll compare with bit number 10. In that first 10 with 7. So 10 here is not possible because they are 2 bit differ. Next 10 with 11 we'll see. 1, 0, 1 dash. Yes, is it possible? So 10 with 11, it's possible. So we can write 1, 0, 1 dash. Now done with 10 with 11, go with 10 with 14. So 1, 0, 1, 0. So yes, it is possible because here 1, here 0 is there, here 1 is there. That means 1 dash, 1 same and 0 is also same. So 1, 0. So what we have done? We compare 10 with 14. So next, that also comparison is done. What is left out now? Comparing index 3 with index 4. So index 4 is what? because all are ones, for every bit it is possible, because only one bit is differ. As you can see, ones, here is also ones, first bit is differ. That means 7 with 15 is possible, 11 with 15 is possible, and 14 with 15 is possible. So what I can write? I'll write 7 comma 15, I'll write 11 comma 15 and 14 comma 15. So if I'll compare 7 with 15, what I'll get? Dash, all ones. If I'll compare 11 with 15, what will happen? 1 with dash with 1 1. Similarly here for the last 1 1 1 dash. So what we have done? So till now we done with first reduction. So decimal numbers, whatever comparison we have done, that we wrote it. Next thing, after writing decimal number, what we'll do it? We'll try to go for next second reduction. So how many times you have to do this kind of reductions? Until and unless there is no further comparison is possible. Till that time you have to go for second, third, fourth, like that kind of reduction. So in that first reduction, as you can see, only single bit needs to be differ. Everywhere there should be a differ of only single bit. So once again you see, for 0 and 8 we compare it. So since only the single bit is differ, remaining is same, so its comparison is possible. So we have written the first reduction of mean term 0 and mean term 8. Likewise we went for next 8 with 5. So 8 with 5 is not possible because here 1, here 0. One bit is differ. Next consecutive bit is also differ. Likewise this bit is also differ. So since there are 3 different bits are there, that comparison will not do it, because we are going for first reduction, only the 1 bit difference needs to be there. That's the reason we have not compared 8 with 5. So 8 with 9 is possible because here is 1, here 0, here 0, here only the single bit is differ. That's the reason we mentioned 8 with 9. Next thing, 8 with 10. So what is 8 with 10? 1 as it is, 0 is there, this bit is differ, that thing should be put in a dash form, and remaining bit is as it is. That's the reason 8 with 10 is also done. So likewise we compare all the bits and we have obtained the first reduction of given Boolean function. That thing we have done. Next thing is that we need to go for second reduction. In second reduction, what we'll do it? We'll try to see what kind of comparison we can do it. In this bit with this one, you cannot do it in exam if you have done 5 with 7, 5 with 10, not like this. You cannot do it. You have to compare one index with next index value. That point you need to keep in your mind while you're going for reduction of the bits. So this is our first class that we are comparing with next class. So now see, first dash, anywhere is there in first dash? Yes, but here 0 0, here 1 1 1. That means I cannot compare this with this. That means this bit with next one is not possible, this bit with next also not possible. Why it is not possible? Because all bits, 3 bits are 0, here is no 3 bits are 0 or 1. That means this first class is not possible with anyone. Now what I'll do? I'll go for next index value. So in this what we have? 1 0 0 dash. Now see this with next class. So 1 last dash do we have? Yes, here is there, no? Here last is dash is there, here is also last with dash. Now see the next bits. 1, yes, it's 1. 0, it's 0. Yes, 0, but here is 1. So that means second reduction means there needs to be 2 dashes. So what I can do it? What comparison I'm doing? What is a decimal number here? 8, 9. Next is 10 and 11. So I'm doing 8, 9, 10, 11. So what is the answer of what is the answer of this one? 1 is there, it's 1. 0 is there, it's 0. Next 0 and here is 1. That means differ, and one more differ. So we got 2 dashes because of the second reduction. So this is comparison of this comparison is done. Now go for next one. So 1 0 dash 0. So do we have dash here? Yes. Here is dash, second point, here is also second. This dash you need to compare it. If dash is matching, that means bits also you'll try to match it if it is possible. So here, yes, it is possible. This bit and this bit I can match it. So that matching I will do it. So by looking into that matching, I can go for reduction of that bit. So what I'm doing, I'm trying to write the reduction of the bit. So what I'm getting here? So 1 0 dash 0. Here is 1 0 dash 1. So I can compare this 8 with 10. Next 9 with 11. So 9 with 11. So what I'm getting? 1 0 dash dash. So I can put it 1 0 dash dash. That is as it is. This and this anyhow repeated only. The same thing is there. So this 2 is done. this 2 is done. Now we compare this class with next class. So here 0 1 dash 1. So third position, any dash is there anywhere? So 0 1 dash 1. If you just see here, yes, this one and this one I can compare it. Dash is there. Here is also 0 dash and 1. So this is not possible. How can you compare it? Because this one bit is differ, another bit is also differ. So this we cannot do it. So go for next. This with next class, you check it out. 1 0 dash 0. No. Again this with next one. So I can compare it. So this you just see in this 1 second here. Here it is there and here it is there. So what is that? 1 first MSB bit is as it is. Next dash is as it is. So 1 dash. Now it is 1 dash. So which one I'm doing? This one and this I'm doing. So this bit is differ, this bit is differ. So what is the answer for this? 10, 14, 11, 15. So 10, 14, 11 and 15. This is done. Next thing we'll try to go for this last dash. Anywhere is there? Yes. Here is last dash, here is also last dash. This I can compare with this part. 10, 11, 14, 15. That means same only. So this comparison and this comparison is over. Now try to write, since it's quite coming double, so we'll write only once. We'll not repeat the same thing. So it's, instead of writing twice, 8, 9, 10, 11 is same. 8, 10, 9, 11 is also same. That means this will write one time because keep on repeating, right? So now what is left out here? This bit is left out, not possible to compare, and this bit is left out, not possible to compare. So we'll write that into some numbers. We'll mention this. Suppose this is your letter A. This is your B, right? This is your C, and this is your D. And what else we do have? So this is also left out. So 14, 15 is done. This is over. 11, 15 is done. So 11, 15, that is also over. 9, 7 and 15. So 7, 15 is not there. So that's the reason it is as it is. That is kept as C. And anywhere, yeah, this is also left out, no? This is your D. This is D. This is your E. So what actually we did? We found all those values. So what are the values we found? The bits which is not able to compare it, that we have given some letters A, B, C, D. So what is that letters? Why we give it? Because that bits further comparison is not possible. So we done with first reduction, we found the second reduction. So the bits which is not able to compare it, if we compare, we are getting more than 3 dashes. That we cannot get it. We need to get second reduction means only 2 dashes. So what we have done, so see once again, for second comparison, 0 and 8 we had single dash. So anywhere single dash is there for the next class? No. That means this is not compared with the next consecutive group. Then next what we have done, this one we try to compare with the next bit. So we do have 8, 9. So 8, 9 last dash is there. So in second class, do we have it last dash? Yes, here is there. So this dash and this dash, if you compare it, 1, 1, 0, 0. Only one, here is 0, here is 1. So the second bit is there. That's the reason we put it for the second one. So that is comparable. Likewise, this class we compare with the next one. So after comparing all those bits, we found A, B, that is unable to compare further. That is as it is. Next is, this is not able to compare with any bit. This is, we are giving letter C. In the procedure we said, right? So the bits which is not able to compare, we'll try to make into next table, that is called essential prime implicant table. We try to find out. So we got now prime implicants. Prime implicants means what? The bits which we cannot able to compare further, those bits are nothing but like a prime implicant. So we found prime implicant is A, B, C, D and E. So these are what actually? These are our prime implicant. So what is this A, B, C, D? We'll try to see. So before doing this one, you just see once what we have done. So students, so we are taking the different values. We do have A, B, C. We found the prime implicants. What is actually the A we had? So we do have A is equals to. So A we do have. A is what? So 1 dash, 1 dash. By taking the, what are the mean values we are taking? So it's 10, 14, 11, 15. So 10, 14, 11 and 15. Next thing we want to write the next value B. So what is B actually? So B, what is the value of B we do have? B is nothing but 1, 0. Dash dash. What is 1, 0 dash dash? By taking the means as 8, 9, 10, 11. So it's 8, 9, 10 and 11. Next we do have C and D and E. Like this we do have prime implicants we found. So what is C value we do have? So C is equals to 7 comma 15 dash with triple 1. 7 comma 15. Like this we have taken D. So what is D actually? So 0 1 dash 1. So what is D actually? By what mean values we have taken? So D is 5 comma 7. So M5 comma M7. Next E is nothing but 0 dash with all zeros by taking mean term M0 and M8. So we had, these are our prime implicants. What we call these things? These are called it as prime implicants. So till now what we have found? We found the prime implicant. Next criteria for us to find out the essential prime implicant. For that what we'll do? We will take the table. Again we'll try to take one particular table. In that we'll write these letters. ABC will write and we'll write on that particular numbers. So first thing what I'm doing? I'm writing prime implicants. So prime implicants. So what are the prime implicants I do have? A, B, C, D and E. These are my prime implicants. So what are the mean terms included in that? So we do have 0. Then 1 is there? No. 2, no. 3, 4, 5. 5 is there. 5. Next 6. So no, where is 6? 7. Yes, 7 is there. 7, 8, 9. Yes, we do have 9. 9 is there here. 10 and 11. So 10, 11. Then 12, no. 14. Directly 13 is not there. 14 and next thing what we had? After 14, 15. So we do have these number of mean terms are included in all. So what we'll do next thing? We'll try to write that cross. What is that cross? Just like a don't care. How do we mention don't care with a cross in your K-map? In the same way, by using the tabular method also, we'll try to write down that particular numbers and we'll write down that specific prime implicant with that particular mean term. So what is A consist of? A consists of 10, 14, 11, 15. So 10, 14, 11 and 15. So for whatever the numbers it consists of, that will put the cross. Next thing, B. What is B consist of? 8, 9, 10, 11. So B consists of 8. Here is 8 we do have for B. 8, 9, 10 and 11. This is for B. Next C. C is what? 7 and 15. 7 and we do have 15. For C. So for the C we are finding this 7 and 15. Likewise we'll go for D. What is D consist of? 5 and 7. For D what we are doing? We are taking 5 and we are taking next is 7. Next for E what will take? 0 and 8. 0 and this is your 8. So we have done for all these numbers. What is left out now? We want to get what are the essential prime implicants from this. What is the meaning of essential prime implicant? If you see in a column wise, there should be a single number should be there. Like see, here we don't have any, 0 is coming in 1 only. This is called one essential prime implicant. As you can see here 5. So 5 is once only. So what is this 5? This is single. Likewise, this is double. So 7 is coming twice, we will not take it. 8 is coming twice, we will not take it. 9, yes, it's coming once. So this is your essential prime implicant. 10 is there, 11 is there and 14. 14 is coming single. So that is what? Essential. There is no further 14. So 15 is coming twice, so we will not take it. So what we are getting now? 14 is coming and 9 is coming once, 5 is coming once and 0 is coming once. So in this way also you can say. So what is that? 0 is coming here only once, 5 is coming here only is 1. Single time anywhere 5 is there? No. Like this, what I can say for 9, 9 is only coming here. For single times it is there. Next 14. So 14 is coming only once. So after getting that, now we need to go for that particular prime implicant. What is that particular prime? A. 14 is there in A. So we have to put A with asterisk. That means A, whatever the A bits are there, that is the including part for that particular essential prime implicant. So A is what actually? It is there for the first one. So we found the first essential prime implicant. Now go for second B. So B is come under this part. Next we do have C. So C is coming for the next part. Likewise we'll take for D. D is also there. So B is having one circle, like particular circle with essential value. So for that we'll put one asterisk for it. That means B is consist of essential prime implicant. Likewise C is there. C, do we have any circle? C here? No. Here is, do we have? No. So we'll not take C. D and we'll take E. So these are nothing but your essential prime implicant we found. Now we'll need to write down the answer for it. So how do I write full answer for it? What is that? What is A is nothing but? What is, tell me A? 1 dash 1 dash. That means this is your X, Y. What is given in the question? W, X, Y, Z. These are variables, no? So tell me, W is 1 and Y is 1. That means first answer is WY by A. Now for B, what is B answer? 1, 0. That means W and X bar. W and X bar plus, next we do have C. Should I have to take C? No, because here there is no circles. Circle is not included. That's the reason we are not taking C. Now go for D. So D has circle? Yes. Is there circle? That is consist of essential prime implicant value. So what we have found, what is this table is called? Table for essential prime implicants. So now what is D actually? So D is what? 0, 1, dash 1. So what is 0 is nothing but W bar. So 1 means X, then dash is there, will not write dash, Z. So this is for W, X, Y, Z. Since it is 0, so W bar, this is X and this is Z. So likewise we do have asterisk for E. So E is what? X bar, Y bar and Z bar. So what is the answer for this? Plus X bar, Y bar and Z bar. So this is the whole complete answer for this tabular method. So what is this actually? What all the things we have covered? First thing, we need to reduce it. We need to make the tabular form and write down the index value, index 0, 1, 2, 3. We got the index. Then we'll compare index 0 with index 1, index 1 with index 2, index 2 with index 3. Only we will write 1, 1 single dashes. After getting this single comparison, we'll go for second comparison. There we have done second reduction. We compare it 2 dashes, right? So after getting this 2 comparison of the bits, we'll found the prime implicants. The one which is not comparable, those are called prime implicant. Now after that we go for table for essential prime implicant by taking those values A, B, C, D, E. By prime implicants we found A values like this. A values we do have, and then we had these values. We write those implicants. You can denote any alphabet. So I'm taking alphabet A, B, C, D by my own defining. This is not the specific one. You should take that particular thing. You can take it any other alphabets. So I got these alphabets. After that, I'll write down the respective, what are the terms it consists of. So I wrote it. Next, after getting the next part, what I did, I want to write the single, whatever the single is there, which don't have further. Means one mean term should not cover in the next prime implicant. Like 0 is covering in only one E prime implicant. Like this 5 is coming only in D. Like this 8 is coming only in B. Likewise 14 is coming in only in A. So that means I need to put this asterisk for it. That asterisk indicate those are essential prime implicants. So we found essential prime implicants from this asterisk. After that only we need to eliminate this C answer. C should not be considered. A, B, D, E. So A answer is this one by taking these values. B answer, what is the B we do have? By taking the B respective value, D and E. So by taking these, combining all, I got my complete answer for given mean terms. This is the how we'll do one particular problem for tabular methods. So in tabular method, you keep on doing this thing, you keep on practicing this part, you will try to get it in detail wise. So thank you for today's class. In the next class, we'll try to solve more problems. We'll try to get in-depth concept of this one. I'll give 2 to 3 problems we'll solve, then I'll give some question for your assignment or for practice. You'll give me the answers for that in the query that I'll give in the next video after completing this problems. So thank you.